raw guest lecture, some sort of stats-themed spin on this month's topic. So start time out for Dr. Gregory Matthews, everyone.
Hello, everyone. What the fuck was that? I got holy shit. Wow. In the spring, I taught a class called Data Science 101, and there was 40 students in it, and they're all right there right now. Welcome to the show. I hope you're enjoying it. Don't tell the chair or something. I don't know. So who am I? My name is Greg Matthews, Dr. Gregory Matthews to all of you. Please use my title. And what I like to do is I like to take the theme of the show, and since my PhD is in statistics, I like to do some data analysis related to the theme of the show. And the theme of the show tonight is essentially neuroscience. Dopamine is neuroscience, right? Right, Dia? Yeah. So I did some stuff with neuroscience. So what is neuroscience? I had to look it up because I have no idea. Neuroscience is the study of the nervous system, and there's two parts of the nervous system. There's the CNS and the PNS and blah, 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 blah. But we all know the brain is the star of the show, right? So I'm going to talk about the brain tonight. And so what I did is I wanted to look at different brains and different animals. And there's a lot of variability in the sizes of brains and the functions of brains between animals. And what I'd really like to do is get a data set, and I'd like to figure out which animals are brainiacs and which animals are two sandwiches short of a picnic, all right? We're going to crown some winners and losers in the animal kingdom based on their brain sizes. So what I did is I went and got some data sets, and that's what I do as a statistician. I got these three data sets that have these three data sets right here, and they have brain and body size for 2,552 unique species. And let's go ahead and crown some winners and losers. So what we're going to do is we're going to look at the brain size and the body size of animals, and we're going to come up with a way of measuring. We're going to come up with a measure that is basically a proxy for which animals are the most intelligent and which are the least intelligent. We're going to hand out some awards tonight, okay? So if we just look at some data, the smallest in my data set is this thing called a myspina. The smallest brain is this thing called a myspina, and the smallest body is a brachymimrex. I don't know what these are. They're the smallest in my data set. That's what Google says these things are. Those are the smallest by brain and body. The largest by brain and body are the sperm whale has the largest brain, and the largest body is the bowhead whale. But we can't just look at the absolute size, right? We can't just look at the absolute size because if the animal is larger, it's clearly going to have a larger brain. It doesn't make them the smartest. It's all about relative size. So how about ratio? What if we looked at body to brain size, a simple ratio of body to brain size? If we do this, the lowest ratio is the bowhead whale, and the smallest ratio is the brachymimrex. It's essentially the same as looking at just the absolute body size. So we need a different way of deciding on who these animal winners are and who these animal losers are. All right? And so what we need to do is we're going to use something called the encephalization quotient. And what we're going to do is we basically are going to build a model based on, we're going to put body size on the x-axis and brain size on the y-axis. We're going to build a model for how big we expect the brain size to be based on the body size. And then we're going to look at residuals. Is this above predicted or below predicted? And then if it's above what we predict, we're going to give them some awards. If they're below predict, we're going to make fun of them. Remember, it's not okay to be racist, but you can make fun of entire species of animals, okay? So if you need a little bit of a, okay. All right. So here's what the data set is. Here's a plot of all the animals on here. So the x-axis here is body size, and the y-axis here is the brain. And it's kind of hard. I mean, there is a relationship between as the body gets larger, the brain also gets larger on average, but it's hard to see a relationship here. So what we do is we come up with a transformation here, and we do this right here. We call this the slow lumberjack model because it's two logs. They love me. I get great recommendations in my great reviews. So we have log body and we have log brain, and this blue line here is the fit, right? So we have an expected brain size. So given an expected body size, that blue line is basically the expected brain size. I've highlighted in red. That's where humans are, and so they're above the line, which means they're an overachiever, right? We can talk, for instance. We can do comedy shows. So we're beating out bugs, for instance. And if you're below the line, that means you're an underachiever, and we're going to make fun of your entire species tonight. Okay. So time for some rizzles. That's what we call results in the stats world. love Snoop Dogg. Rizzles. Okay, so just to give us a little bit of a baseline here, these are animals that are these animals. This measurator, this number 1, basically says that these are animals where the brain size is exactly what we expected based on their body size. So these are sort of the average people. These are the people you went to high school with, and they're not like a regional bank manager. You know what I mean? Like they're doing okay, but they're not like super overachievers. They are the lemurs of your life. So we got a rock squirrel, we got the Chirospiny mouse, small-toothed sportive lemur. Look at him. Look at this guy. He's completely average. She's like, I got a lot of B minuses in high school. All right. So now let's go through, and we're gonna do. If you remember your biology, King Philip came over for great spaghetti. We're gonna go through these different things: phylum, class, order, family, genus, and species. And we're gonna go through these, and we're gonna look and see who are the winners and the losers. The numbers you'll see here. So a 1.00 means that it's basically exactly like we expect. A number greater than 1 means that they're an overachiever. A number less than 1 means they're an underachiever. Okay? So let's start out with phylum. This is the phylum data that we have. We have most of this data here is chordata. We have some arthropods, and we have a few examples of annelida and mollusca, but most of these are chordata. You can see that chordata is 1.22, and then these are the average encephalization quotients for the animals in that phylum. Phylum's not that interesting. Let's look at class. So in class, we have, these are the 8 classes. Birds actually win. Birds are beating out mammals. Birds are, they're pretty smart, and that's why we should all fear them with our lives, because I hate birds over here. What is the sign on Loyola's campus? What is the sign everywhere? Do you know what I'm talking about in the summer? No, red-winged blackbirds. There's signs all over Loyola's campus. They're like, the birds will attack you. And I'm like, really? It's all over campus. So birds here are number 1, and mammals actually come in at number 2, which is what we are. So we're in the second highest class here according to these encephalization quotients. What I'd like to do, I'd like to point out here that clitellata down here at the bottom is actually a worm. It's not to be confused with the frozen coffee drink that's made with very, very hard to find beans. That's a top shelf taxonomy joke. All right, that's as good as they get. My wife wrote that. She's going to be so pleased that I told that. All right, so let's look at order here for a second. So these are the top orders. We have primates, cetaceforms, pastoriforms. These are birds, basically. We have the primates. We have some birds here, and we have this little guy. He's a Microbiotheria. I don't know what he is, but he's a 1.73, so he's pretty smart. I really think parrots are interesting. I don't have a joke for it, but I thought parrots interesting at number 2. I mean, they can talk, I guess. That's pretty impressive, if you're impressed by that kind of stuff. At the bottom here, the absolute bottom order I have is Diptera, which are basically flies. This kind of makes sense. The bugs aren't that interesting, but Crocodilia is way down at the bottom. These things are just massive, stupid biting machines. And then we have Blatodia, which is the cockroach, and we have Testudines, which are turtles. These are giant sea turtles. And, oh, yeah, you feel bad for the sea turtles? They're real dumb. Okay. So let's look at family. So remember, the big animals here, this crocodile and these turtles, and we have some bugs. Everyone knows bugs aren't smart, but the crocodiles and the turtles, they're really in a battle here for the dimwits of the animal kingdom. So for family, these are the top ones. Still, again, it's monkeys and birds. These are the ones that are, these are the families. We got some Cebidae, Icteridae, Cerathopidae, and Passerellidae. Look. I'm a numbers guy. I don't do words, so I can't pronounce these things. All right. The losers, number 1, Blatidae. This is the common cockroach. Number 2, we're going to see him again. It's the fucking turtle. These things are so... No. They're real dumb. They're cute, but they're real dumb animals. Number 3, we got the crocodile, the absolute dipshit chewing machine. And then we again have Drosophilidae, which are flies. They've switched orders a little bit when you group these by families, but it's still sort of the same usual suspects. So we're going to need a tiebreaker. We've done 2 of these. We're going to need to look at the species level. So at the species level, let's look at the losers first. So number 1 is the American cockroach. This is the species of animal that in my data set is the absolute dumbest, right? These things are just walking around. They can survive nuclear apocalypses, but they don't have a single thought in their brain. They don't know what they're doing. They're just walking around living, right? That's my description of cockroaches. They're just living. We have the golden silk orb weaver. And then what do you think number 3 is going to be? It's the fucking turtle. So we're literally think about this. It goes cockroach, spider, turtle. It's up there with bugs. These things are just giant, dumb, floating objects in the sea, and you shouldn't feel bad for them. It's not okay. They're fine. All right. Maybe they're so stupid. They're blissfully ignorant, and they're the happiest animals on earth. I don't know. Let's look at some species overachievers. So this is 4 through 6. The numbers are way off. So this is the 4 through 6 in species overachievers. We have the white-cheeked spider monkey on the left here, and we have 2 dolphins. We have the northern right-whale dolphin, and we have the white-beaked dolphin. Okay? Let's look at the top 3, though. The top 3 are going to be the rhesus macaque at 4.7. So there's 2 left. What do you think is the top 2? What am I trying to get at here? What should be number 2? It should be some kind of another monkey again, right? Number 2 is actually humans. We are not number 1 in this data set. I've chosen this picture to represent our species. I think it's pretty accurate. I'd like to remind you though, this is the average. This is the encephalization quotient for average humans. There's a lot of variability in humans. On one side we have rocket scientists and theoretical physicists, and on the other side we have people who ride recumbent bikes and Republicans. Oh, sick burn! Sick recumbent bike burn. All right. And number 1, you're probably wondering, who's above us? The green monkey. Look at this guy, all smug and shit, looking down on humans like I'm way smarter than you. 5.8. What's going on over here? You like green monkeys. You're a real drunk right now, aren't you? She's having a good time. She's moving to California. She's probably had 45 beers. All right. Going away, right, Abby? She wants me to leave her alone. All right. So now. Oh boy. All right. Well, so okay. What would happen if we let males and females be their own separate species? How would this change the rankings? So I got a lot of controversial things to say. All right. So let's let them be their own species tonight, and we're going to look at how the rankings are changed. So here we have the top 4 are the same. We're going to fill. So males and females, they both end up in the middle there. They are ranked 2 and 3. But who is ranked higher, males or females? Females, of course. Yeah, she's right. And you can see here why. I mean, as a representative of the human male species, I gotta give it to the human female species. Golden Girls are way better than fake sports. It's sports entertainment. Oh my god. All right. So those are the species overachievers. So the human male is objectively, quantifiably less intelligent than the human female, which is why it's so impressive that we've gone 894 and 60 for Nobel Prizes, 46 and 0 for U.S. presidents, and 57 and 0 for Super Bowl MVPs. It's really a tale of an underdog sex overcoming their biological impediments to really achieve. I'm going to get attacked after the show. And rightly so in this time. So finally, I'd like to say the ratio of these encephalization quotients, 5.63 to 5.2, is 1.08. So it's about 8% higher for females. And so I wanted to give you something to compare this to. And so I found 2 other animals where the ratio of their encephalization quotients is this ratio. And it's the southern yellow-eared bat, which is 1.76, and the pinyon jay, which is 1.62. They have about the same ratio. I randomly found this as an example, and then I looked at what their actual species names were, and I swear to God this is true. The southern yellow-eared bat is the Vampressa pusilla, which is Latin for vampire vagina, and the pinyon jay is the ginormous cyanocephalus, which is Latin for giant blue penis. And so this is how you can remember the difference between men and women. And by the way, if you Google giant blue penis, you get there's a nice mural in Sweden somewhere, and if you Google vampire vagina, you'll realize you shouldn't have Googled vampire vagina. What have we learned today? Don't confuse worms with frozen coffee beverages. Men are overachievers, and turtles are the dipshits of the deep. Oh my God, the turtles! All right, follow us on Uncontrolled Variables. Look at him, he's so stupid. I'm on blue sky.
You've gone for Dr. Greg Matthews, everybody. All right, is it for your next comic?